Hello everybody, welcome back to my channel. Here we are with our real-time example of LDA and we are going to explore on the same on today's video. Let us start. So here we are with our practical part of our linear discriminant analysis or LDA, and we have taken the iris dataset here and the CSV file I have loaded. So this iris is available in your Seaborn library and in scikit-learn library as well. You can try that. And before moving ahead, guys, I have promised you that I am going to share this Bayesian search CV algorithm and the method. So the same thing I'm going to share, but I just thought of showing it to you before sharing. Like how it works, it's same thing, guys. It's same thing, but only thing is you need to remember that here we are using the Bayes search CV, and that is again present in. Let me just scroll it up. That is present. That is not a part of your scikit-learn. That is part of your scikit-optimize. I have already written this. You can see that it is a part of scikit-optimize, and initially you won't be having scikit-optimize. You just need to use pip install scikit-optimize in your prompt, Anaconda prompt, and after that you can run this, and this is how we can import from skopt scikit-optimize. The short form is skopt, just scikit-learn, sklearn. Similarly, skopt, we are importing Bayes search CV. We are importing Bayes search CV, and here this is nothing but we are trying to impose the different kind of what I can say, the part, like how we are going to initialize or how it is going to segregate your values or how it is going to take the list from or sampling. All this is all sampling help. These all are like skopt space. Then again we are this is a car price prediction, guys. So we have taken the dependent, independent, then dependent. This is the train test split I have done. Then I have created a pipeline, same thing. This is elastic net regression algorithm I have used. I have told that random state should be 42 and max iteration should be 5000. Then you can see this is the initializer, right? Where in case of grid search we are using grid, right? Param underscore grid, then param underscore of initialization. Then here we have search underscore space. This is the property by which we are initializing all our hyperparameters. So this is one of the hyperparameter for elastic. This is another, right? And instead of just writing list, I have used real. And real is going to take, if it's a negative or positive, whatever the values are there, it is going to take that and it is going to consider for sampling method, right? That's how it is happening. And in behind it is working with cross validation, right? So this on this the cross validation will happen, and the prior is log uniform. So that's how I am initializing with search underscore space, and this is important. So instead of directly using my elastic net, what we are doing, this is again one type of algo. So I have taken my object, then estimator should be my elastic net pipeline, so I have taken that. Then search spaces should be search space. Then iteration, I am telling that number of evaluations, right? This is my number of evaluation. And scoring for regression, this is the one, mean, absolute error. And cross validation, I am telling 5-fold cross validation should happen. Then all these things I have already explained you. Then after that we are fitting the model, right? And once, if you see that once it fit the model, and this is the verbose part, right? Verbose means it is going to show you the status of each sampling or the each way how it is happening. And this is how my Bayes search CV looks like. Then after that I'm getting my score and the params, best params dot items. What are the parameters I'm getting, right? Then that's how, guys, that's how we are getting, and this is how my MA, MSc and R2 score is coming up. I will share all these things to GitHub. Please go ahead and explore that. Now let us come back to our LDA part, linear discriminant analysis, and we are performing this on the iris dataset. So what is the first step, guys? We have to import our model. So I have done that. I have imported my module. Then this is my I'm loading my CSV. This is my head, and if you see my head, so iris is a it's a class of flowers, I believe, and here different for that particular class there are different species or different kind of flowers present. One is setosa, then verses or something like that. Then I will explore you what are the unique classes present in this, but let's explore on what are the other features present in this. So we have sepal length, sepal width, petal length, petal width. Then data.info, what are the how many rows are present. This is a small data set. So 150 rows present and all are non-null and null values are not there, and we have int, float and object combinations present. This is my descriptive statistics. And I was talking about the class, right? How many classes are present in this? So let us see that. So if we'll see that how we can get the count of unique class, guys. We have the value counts. So if you type unique, it is going to show you the unique values in that. However, if you just do value count, it is going to give like this, right? I have already covered these things during our pandas and pandas classes, right? So we have 3 different classes here. So it's a three class classifier, not 2 class. So we have iris setosa, iris versicolor and iris virginica, right? These are the 3 classes, and all you can see it's a balanced data, right? Again, we have all 3 classes present equally. That means it is really fit for our LDA analysis. Then what is the next step, guys? I do not want my ID column to continue or to go ahead, so I am dropping it. So after dropping, this is my head. Then I am going ahead with heat map. And for my heat map, I am using, okay, let me just take this there. I'm just telling that I have all my numeric columns present in my X, so I am going ahead and getting my heat map. So this is my heat map. Then we have got our X and Y, right? And now it is, I do not want to perform much on this because this is a very small data set, and if we'll perform more in this, then it is going to be overfit. So let us go ahead and explore our LDA, what are the components present, how we are going ahead with the analysis. So what is the first step, guys? We have got our X and Y, like our independent and dependent. Then what is the next step? We have to get train test split, right? Then for these kind of algos, it is always better to scale it down. Always it is better to scale it down, so it is easier for the model to understand. So standard scaler I have taken. Then this is how my discriminant analysis getting initialized. So in sklearn we have a module discriminant underscore analysis, and we are importing the library linear discriminant analysis, right? Then we have metrics. So different metrics are present, and these are the metrics how we can initialize. We have accuracy underscore score, confusion underscore metrics, classification underscore report. Now I'm going ahead and I'm getting train test split. So with that I'm getting my X train, X test, Y train and Y test, and test size I'm taking 0.2. That means 20% of data is going to be my train data, test data, and another 80% of my data is going to be my test data. My bad, guys. 20% is going to be test, 80% is going to be train. Simple. And And we have another property called stratify, right? So what is the meaning of stratify, guys? So in case of classification, stratification will come into picture, because just consider that when we're talking about the class, right, the output type or the target variable is class. So you should consider equal amount of classes in each split, right? In each split, or when we are talking about the train split, equal amount of classes should be present there. Otherwise, there is a chance that the machine will not understand, it is not going to give it a better output. Then, in case of test set or the test split, again in that case also, the amount of data should be distributed equally. So, to handle that, stratification is important in case of classification algorithms. And what we are trying to say, that with this stratify equal to y, that means I'm telling that whatever the classes are present in my y, that should be equally distributed among my x. Then what is the next step, guys? We are standardizing our features. So how we are doing it? What is the method, guys? We have scalar, right? And what we are trying to scale? So when I'm talking about train, we can do fit transform, right? But when we're talking about test, we cannot fit them, because we do not want our model to learn the data, or whatever the validation data set we have created. We do not want our model to learn the data, because when we're fitting the data, that means we're telling that my model should learn this data. When we're not doing fitting and we're just doing transform, that means it is just going to scale it down. So this is the moral of my these two lines. Then what is the next step, guys? We are okay, this is what my scaled, this is how I am reducing my dimensions, right? So here I am doing, so here what I am doing, I am using n components equal to 2. That means I have 3 classes, and what I told you guys, in case of 3 classes, by default it is going to reduce to 2 or 1. If I'm removing this also, then by default it is going to convert that to 1D. So that is one of the important step when we are applying LDA. This step is going to decrease the dimensions. And I am again I'm getting my train and test, and this is how I'm getting my train and test. Then after that I am using my final classifier. So I'm just telling that LDA underscore classifier is my object, and I'm fitting my model. What I'm fitting my model, what I'm fitting. So X train scaled and Y train. That means I'm telling my X train scaled one and my Y train should be there. Then if you open this parameters, you can see solver is SVD, then shrinkage none, priors none, n components none, store covariance false, total then covariance estimator none. So here none means that it is taking the default one. So this is one method and this is another method, guys. So if I'll use this n components equal to 2 here, and if you'll open this, you should be able to see n components equal to 2, right? So these are the two different methods I have shown. This is how we can do it. So before moving ahead or before going ahead, you can do this LDA.fit transform and like this, and another way you can do this, right? Another way you can do this, you can just directly use the X train scaled and Y train. Then after that I'm predicting. Then once I'm predicting, what is the next step, guys? We have to know the accuracy score and all the evaluation metrics. So this is what I'm getting my evaluation metrics. My accuracy is coming 1 because here the data set is small. That's why we are getting a perfect score. Then this is my confusion matrix. And this matrix is containing my all true, positive, true, negative and everything in this. Then we will explore that in our upcoming videos, guys. How our confusion matrix was, how we are converting the precision, recall, F1 score, everything we are going to understand. How this classification report is getting read. Then all these things we'll see. But for now, let us understand that Now whatever I have my output, I want to show you how we can get it in my 3D plot. So for 3D plot, what are the things we need, guys? We need 3 axes, right? So I am getting my 3 axes, and those 3 axes I'm using. I'm telling my x should be sepal length, my y should be sepal width, and my z should be petal length, because 3 axis, 3 values should be there, right? 3 features should be there. And I'm just telling my label should be data spaces. Then this is how I'm going ahead. Just understand this. This is my plot dot figure. I'm just setting up my plot. Then I'm telling my axis should be subplot and projection 3D. Then I'm telling my scatter. All the data points should be in scatter format. So here I'm telling my x, y, z should be my scatter plot. Everything should be there. Then factorize labels 0. Then I'm telling my transparency level should be 50. Then these are my labels. I am able to see like whatever the labels, right? This should be visible, sepal length, sepal width, and petal length. Then this is how I can get my grade and everything inside that. So this is how I'm getting my 3D. So you can see that how my data, or how my output is, my classes, different classes, Satosa, Versicolor, and Virginica are getting plotted here. This is just for visualization, guys. You don't have to remember all these things. Then after that, what is the next step, guys? We can get our variance, explained variance. So what is my variance here, guys? What I'm trying to do here? You can see. So what I'm trying to understand from my explained variance ratio is my 99%, whatever the data I have, all those data are correlated 99% among each other. That means the variance is better in this case. And then after that, we will understand the coefficients, LDA dot coefficient. This is how we can get our coefficients, guys. Or why we are performing coefficients, guys? What is the significance of getting coefficients? With this, we can understand the feature importance and how it is getting segregated, guys. So we have 3 different classes, right? So this one line is for one class. So this is suppose we have 3 different classes. One is a Satosa, Versicolor, and Virginica. So this line is for Satosa, right? This line is for Virginica, and this line is for Versicolor. So whatever 3 classes. Then after that, we have taken 4 features into consideration, right? So for all those 4 features, this is the coefficient for sepal length, this is the coefficient for sepal width, this is the coefficient for petal length, this is the coefficient for petal width, right? With this, we can be able to understand how important this feature with this coefficient we can understand. Then we are understanding means. Why we are getting means, guys? Mean value for each original feature, right? What we understood during our LDA concepts, it is going to consider the means first, right? So the same thing we are calculating for each original feature for each class. We are getting it. So this is my feature. This is my one class. This is my another class. This is my third class, right? So when we are talking about sepal length, this is the mean of all those values. When we are talking about the sepal width, this is the mean of all those values for the class Setosa. Then same thing is applicable for class Versicolor, class Virginica, right? Then with LDA dot priors underscore, we can be able to know that how balanced this data is. So we can see that all those 3 classes are present with 33.3%. Like in total, it is combiningly 100%, right? So we have 33%. That means it's balanced data. I have already shown you that, like we have 50 data sets present. Then this is how I am getting my output or my projections. Whatever the projections we got, this is how it is coming up, or this is how it's creating my output. You can see that. or after converted to a new plane or new axis, this is how it has segregated. You can see this is my iris setosa, and this is my iris versicolor, this green one, and this is my iris virginica after my LDA. This is the output. So we understood our LDA, guys, and we will meet during our next video. Thank you. That is all for now. We will start with the evaluation metrics and the different kind of it which are getting used in our classification algorithms, and that is a very important part of your classification algorithms and mostly asked interview questions throughout your AI and ML interviews. So go ahead and start subscribing if you really like the content. Hit the bell icon while subscribing so that you will not miss the latest updates. Like, share your comments, share your valuable feedback, and see you till next time. Bye, tech.